नमस्कार दोस्तों, वेलकम टू गेट वाला। मैं हूं सतीश कुमार दुरिशेट्टी, फैकल्टी ऑफ माइक्रो प्रोसेसर्स। मैं आप सब लोग को यहाँ स्वागत कर रहा हूं। आज हम डिस्कस करेंगे मिशन इंडियन इंजीनियरिंग सर्विस पर माइक्रो प्रोसेस का PYQ सीरीज। आई होप आपको पता होगा, माइक्रो प्रोसेस में प्रीवियस ईयर्स में बहुत अच्छा क्वेश्चंस आ चुका है, स्पेशली सब बेसिक लेवल से। स्पेशली हमारा सिलेबस में 8085 है, 8086 है। समटाइम्स हमको 8051 का बेसिक्स भी पूछ रहे हैं। प्रीलिम्स पेपर में भी आपको बहुत अच्छा क्वेश्चंस आ चुका है। आपको फंडामेंटली क्या होता है ना, माइक्रो प्रोसेसर हमारा बीटेक में हमने 8085 8086 पढ़ चुका है। वहां से आप क्वेश्चंस आ सकते हैं। ओके, सो जल्दी से जल्दी ज्वाइन करो बेटा। जितने लोग लाइव में हैं मुझे एक बार वॉइस कंफर्मेशन कर दीजिए, ऑडियो वीडियो सब कुछ क्लियर या नहीं। अगर एक बार क्लियर है तो हम फटाफट स्टार्ट कर सकते हैं। चलो, ओके, स्टार्ट करेंगे। माइक्रो प्रोसेसर सब्जेक्ट EC में। First of all, the questions here asked is topics to be discovered. Topics to be covered is we are going to discuss about especially 8085 microprocessor. We are going to cover 8085 microprocessor, its basics and its architecture. Architecture we are going to discuss, and इसके साथ साथ हमने इसका प्रोग्रामिंग मॉडल, and instruction set classification. Instruction set. So try to understand this. 8085 microprocessors, basics, architecture, programming model, and instruction set. So first let us start with the first question. What is the difference between microprocessor, microcontroller, and microcomputer? So actually that should, the order should be like this. The question should be between microprocessor, microcomputer, and next we are also asking microcontroller. So there is a fundamental question, a short notes. You can also ask you the question, write a short notes on what is microprocessor, what is microcontroller, what is microcomputer also. Can anybody distinguish what is microprocessor, what is microcontroller? Microprocessor क्या हो सकता है? What can be the microprocessor, what can be the microcontroller, what can be the microcomputer? Okay, so how to define here? So microprocessor is distinguished as what? So if you see the definition, microprocessor means it is a CPU on a single chip. Simply speaking, what we can call it as, we can call it as CPU on a single chip. Microprocessor is treated as CPU on a single chip. So it is also called as general purpose programmable device without a built-in memory. So आपको ये याद रखना है, माइक्रोप्रोसेसर में built-in memory नहीं रहता है। माइक्रोप्रोसेसर में built-in memory नहीं रहता है। Yes, please make a note of this. this microprocessor is defined as CPU on a single chip. So 8085 microprocessor is there and 8086 microprocessor are the examples. And remember this, for microprocessor memory is always external and input output device are also external. So हमेशा ये याद रखना, माइक्रोप्रोसेसर को इनबिल्ट मेमोरी नहीं रहता, माइक्रोप्रोसेसर को हमेशा एवरीथिंग विल बी एक्सटर्नल. सो जो लोग IES कन्वेंशन पेपर में लिखना चाहते हो, दिस रिगार्डिंग दिस यू हैव टू राइट वेरी केयरफुली. फॉर माइक्रोप्रोसेसर एवरीथिंग विल बी एक्सटर्नल. Okay, memory and IO devices will be external. So examples I have given 8085 microprocessor this. And always remember is different as CPU on a single chip. And always remember this particular microprocessor is a general purpose device. This particular microprocessor is a general purpose device. Microprocessor is a general purpose device. Always remember, so microprocessor is not a specific purpose, it is a general purpose device. It's a general purpose device. Okay, so this is the point. Chalo, next. What is microcomputer? What is microcomputer? ध्यान से देखो, whenever this microprocessor is assembled with RAM, ROM and IO ports together. So when a microprocessor is assembled like this, it is assembled with memory, external peripherals like RAM, ROM, IO ports, then it is called as microcomputer. So ये है microprocessor. A microprocessor के लिए RAM, ROM, input, output and other external peripherals are connected like this. So then it is called as microcomputer. So microcomputer की examples है. So what are the examples? Microcomputer examples, they are calculator, motherboard. So these are the examples for the microcomputer. Next comes microcontroller. What is microcontroller? So when all this particular microcomputer is fabricated on a single chip, then उसको हम बोलते हैं microcontroller बोलते हैं. So microcontroller on a single chip is called as microcomputer on a single chip. Pura everything is fabricated on a single chip. For example, in the entire these things, so there is a space for microprocessor, there is a space for RAM, there is a space for ROM, there is a space for IO ports, there is a space for serial data communication, and there is a space for timer. So all these together, then it is called as microcontroller. So example for that is 8051 microcontroller. Example for this is 8051 microcontroller. Okay, so please make a note of this list. So I have given the clarity between what is microprocessor, what is microcomputer, what is microcontroller. Okay, microprocessor means a CPU on a single chip. Microcomputer means whenever the microprocessor is associated with so many peripherals, uska microcomputer bolte hain. When the entire microcomputer is fabricated on a single chip, uska hum bolte hain microcontroller bhi bol sakte hain. Okay, so this is what the things. So if you see now some important points about the bus signals. So what are the various bus signals? So bus signals present in microprocessors. So these also a short answer question can be expected. So if you see the bus signals, what are the bus signals? We're having three bus signals: address bus, data bus and control bus. See, address bus is always unidirectional. Always remember that. आवाज clear आ रहा है? Address bus is unidirectional. Address bus is unidirectional. Data bus is bidirectional. Address bus is unidirectional, but data bus is bidirectional. Control bus is one direction. So these are the things. Okay, so when microprocessor is interfaced with memory, with address bus, data bus, control bus, then that is a system, a complete system. Microprocessor जो भी करना है मेमोरी से लेना देना काम रहता है, इसके लिए उसको बस का रिक्वायरमेंट जरूर होता है. सो बस 3 टाइप्स रहता है, एक एड्रेस बस है, डाटा बस है, कंट्रोल बस है. डाटा बस बाई डायरेक्शन है, कंट्रोल बस सिंगल डायरेक्शन है, एड्रेस बस यूनि डायरेक्शन है. Okay, चलो next let us go for this particular things. Okay, so some basics. I want to give the basics of memory and all those things. In microprocessor, some of the students may be aware of these basics. So in microprocessor, all the things we are going to write in the form of bits and bytes. So bit means what? 0 and 1, either 0 and 1. Nibble means 4 bits. 8 bits we are calling as 8. 8 bits को हम बोल सकते हैं byte बोलते हैं. 16 bits को हम बोल सकते हैं word बोलते हैं. Okay, 1024 bytes को हम बोल सकते हैं 1 kilobyte बोल सकते हैं. Okay, so if you see the 8085 microprocessor, that is a third generation microprocessor, second generation microprocessor, its data bus capacity is 8 bit and its address bus capacity is 16 bit. Okay, so data bus capacity is 8 bit here, so this is the 8 bit and the address bus capacity is 16 bit here. So this is A0 to A15 and this is D0 to D7. D0 to D7. Okay, so now if you see For example, if I have three address lines, if I am A0, A1, A2, if I am having three address lines, I can access from 000 to 111. So if I am n address lines, if I'm having n address lines, I can access up to 2 power n memory locations. I can access up to 2 power n memory locations. Suppose if I have 16 address lines, if I have 16 address lines, I can access up to 2 power 16 memory locations. 2 power 16 memory location. So 2 power 6 into 2 power 10, 2 power 6 means 64, 2 power 10 means kilobyte. So the right answer is 64 kilobytes. So the max memory that can be addressable by 8085 is 64 kilobytes. So please make a note of this information. We're having 16 address lines. 16 address lines will access up to 64 kilobytes. Done? Chalo. Now let us see. I'm having 16 address lines actually. So 16 address lines means the range will be what? So if you see the range, so this is the range. I'm having 16 address lines. So 16 address lines means they're starting from A0, A1, A2, A3, A4, A5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. So now A0 to A15. So total we're having 16 address lines. So 16 address lines means 16 zeros and 16 ones. So total will become as 4 ones, 4 ones, 4 ones. That will become as double F, double F. Okay, so double F, double F. So that is the range of the memory location. So the range of the memory is, it starts from 4 zeros H to ends at 4 FHS. So that is the range of the memory. So the range of the memory is 0000 to double F, double FH. Note down that. This is hexadecimal number system. So if you see the hexadecimal number system, the number system is starting from 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 in hexa is called A, 11 in hexa is called B, 12 in hexa is called C, 13 is called D, 14 is called E, 15 is called F. Okay. So the range is 4 zeros to 4 FH, because 16 zeros and 16 ones, 16 zeros and 16 ones, 4 zeros are called zeros. So this is our 0. So this is called another 0, this is called another 0, this is called 0. So 4 ones we call it as F, this 4 ones we call it as F, this 4 ones we call it as F, this 4 ones also we call it as F. So the range is double F, double F. Chalo. So that is a representation of a memory chip. A memory chip is generally represented like this, 64 KB na. So that is represented like this. 64 means 2 power 6, kilo means 2 power 10, B means byte. So 2 power 16, 8. So this is a 64 represent. A memory chip always represented as what? 2 power n cross m. So where n represents the number of address lines. Always remember address lines is unidirectional. It's not correct here. So address lines is always unidirectional like this. So address bus is always unidirectional. So these address lines, and the number of data lines is this. Data lines is bidirectional. N is the number of address lines, M is the number of data lines. N is the number of address lines, M is the number of data lines. Okay. Now if you see the programming language, what understands, what microprocessor can understand? See what microprocessor can understand. Microprocessor can understand only ones and zeros. So microprocessor understands only machine language only. It understands only machine language. So microprocessor cannot understand a program written in assembly language. A software tool known as assembler. A software tool known as assembler. A software tool known as assembler. There is one software tool called assembler. So assembler is a software tool which converts the assembly language program to machine language too. Similarly, in high level language, we have a tool called compiler. So compiler will convert high level language like C language into the ones and zeros. Assembly language will convert machine level language, assembly language into machine level language, like move and add all those things. That assembly language is converted to machine language, zeros and ones. Okay, so a software tool known as assembler is used to convert assembly language to machine language. Now the question here, it can be asked a question like this. Now directly we are moving for the 8085 architecture. सर मैं स्टेट में वाटर सप्लाई डिपार्टमेंट में AEE हूँ, मुझे ESC के लिए प्रिपेयर करना चाहिए, क्या प्लीज गेट? अगर आपने ESC प्रीलिम्स क्वालिफाई हो गया भैया, आपने ESC प्रीलिम्स क्वालिफाई हो चुका है, this is for the mains examination. So those who are qualified the prelims examination, for them I am giving this mains questions. अगर आपने prelims examination clear हुए तो आपको ये useful हो जाएगा. So first you have to clear the prelims exam. Okay, first you have to clear the prelims exam, my dear. Explain the 8085 architecture. So if you see the 8085 architecture, so this is a complete architecture of 8085. So 8085 architecture is having some register model, 8085 architecture is having some accumulator, temporary, instruction decoder, instruction register, timing and control, so interrupt control, serial IO control. Okay, so that is the architecture of 8085. Now if you see the accumulator, so first let me talk about the programming model. First of all, let me give the introduction of the programming model. So first let us go step by step in 8085. No sir, sorry sir. So first आपने prelims clear करना भैया, it is only for the mains examination. The people who are qualified the prelims, they can go for the descriptive. IES two stages का होता है, एक prelims होता है, एक mains होता है. Prelims होता है, mains होता है. Prelims is for objective, and once the prelims is qualified, prelims is having paper A, paper B, general studies and technical. In general studies, you're having some general knowledge, GK, current affairs, history, geography, and some Indian constitution related questions. Then you will go for the technical subjects. In technical ECE के लिए ECE subjects है, electrical subjects है. वो पूरा qualify होने के बाद mains examination होता है. Mains examination is completely descriptive paper बेटा. Okay, चलो explain the 8085 programming model. So if you see the programming model means what are the registers present in it. Okay, so please make a note of these registers once. Okay, then you can follow this, no issue. Sir, our MPSC is same pre-mains, descriptive and interview. Yeah, then you can follow this, no problem. Okay, chalo. Now if you see the programming model of this, the registers are accumulator register. Next comes the flag register. So these are registers B and these are registers C. Next D, E, H, L. So if you see here, A is the accumulator. A stands for accumulator, my dear. A is the accumulator register. B is a 8-bit register. C is a 8-bit register. So together we can take it as a BC, that is a 16-bit register. D is a 8-bit register. E is a 8-bit register. Together we can take it as a DE, that is again 16-bit register. H is a 8-bit register. L is a 8-bit register. Together we can take HL, that is a 16-bit register. Okay. Next comes a stack pointer. Stack pointer is also a 16-bit register. Next comes the program counter. Program counter is also a 16-bit register. Okay, stack pointer and program counter also we have written. Okay, so please make a note of these points. Each and every register is having its own specific purpose. each and every register is having its own specific purpose. So now let us go for एक एक register के बारे में discuss करेंगे. So first comes the accumulator register. So what accumulator will do? Accumulator is a 8-bit register. Accumulator is a 8-bit register. That is a part of the arithmetic logic unit. What is the purpose of this register? It is used to store 8-bit data and to perform arithmetic and logic operations. So you can perform arithmetic and logic operations on the accumulator. Arithmetic and logic operation. So the result of an operation is stored in the accumulator. So the result of operation is completely stored in the accumulator. The accumulator is also identified as register E. The accumulator is also identified as register A. Okay. So as the name indicates, it accumulates the result. It goes on adding the contents. Okay. Next comes the general purpose registers. The 8085 has 6 general purpose registers. So what are they? B and C as a pair. So together 2. D and E as individual and together DE, H and L as together. So they can be combined as register pairs. As I told you, BC is one register pair, D is one register pair, HL is one register pair. Okay, to perform 16-bit operations. So the programmer can use these registers to store or copy data into the registers by using data copy instructions. Got it? So BC is a 16, D is a 16, HL is a 16. Okay, chalo. Now some more questions we'll discuss here. As I told you, so the programming model, as I told you, we're having program counter and stack pointer also. So what is the purpose of programming counter? So program counter, as a name indicates, it counts counter. That means it's the direction where to go next. So it represents the address of the next instruction to be executed. The 16-bit address of the instruction which is to be executed next, where to go. So program counter, what it will do? So there are only 2 16-bit registers in the microprocessor of 8085. There are 2 16-bit registers only present. One is stack pointer, other one is a program counter. So the function of the program counter, if you check, the function of the program counter is to point to the memory address from which the next byte is to be fetched. So when a byte is being fetched, the program counter is incremented by 1 to point to the next memory location. Okay, so like that it happens. So every time when it reaches the next instruction, when a byte is being fetched, the program counter is incremented by 1 to point to the next memory location. Next comes the SP. SP stands for stack pointer. So what is a stack pointer? Stack pointer means there is a memory location called stack. So if you see, this is a stack. So the stack contains the top of the stack. So this is the top of the stack, my dear. So this top of the stack, we can call it as SP, stack pointer. So top of the stack is represented by stack pointer. So whatever that you want to do, you have to do on this particular top of the stack. You want to push or you want to pop, whatever that you want to do on the, yes. Sir, मैंने गेट ESE साथ में प्रिपेयर करना चाहूँ. Yes, प्रिपेयर कर सकते हो क्योंकि 70% of the syllabus is same. 70% of the syllabus is same. So you can follow, no issue. Okay. लेकिन प्रीलिम्स के लिए ये प्रिपरेशन यूजफुल होगा, लेकिन मेंस के लिए आपके एक्सक्लूसिवली मेंस के लिए आपने प्रिपेयर करना पड़ता है. और मेंस यू हैव टू टेक केयर ऑफ लॉट ऑफ थिंग्स. डिस्क्रिप्टिव पेपर है ना, मेंस पेपर, यू हैव टू टेक केयर ऑफ थिंग्स. आप ले सकते हैं, हमारा फिजिक्स वाला से गेट प्लस ESE बैचेस हैं, गेट प्लस EHE बैचेस आप ले सकते हैं. Okay, so it points to memory location, read and write memory called the stack. The beginning of the stack is defined as loading a 16-bit address of the stack pointer. Okay, chalo. Now, so what we can do now, we can push the elements into this. We can push the elements into it. So when you push, the stack pointer decrements. Similarly, when you can pop, the stack pointer increments. So on stack, we are going to perform 2 operations, push and pop operation. Okay, please remember, when you perform push operation, the stack pointer will be decremented by twice, and that is going to be the new top of the stack, my dear. Stack pointer is going to be decremented by twice, so that is going to be the new top of the stack. In pop operation, after popping, the stack pointer is going to be doubled, and that is a new top of the stack, my dear. That is a new top of the stack. Okay, so note kar do yaar. Sure. Now let us move for the instruction set. So next question expected here is, explain the instruction set of 8085. Explain instruction set of 8085 microprocessor. Okay, so if you see the 8085 instruction is having almost 256 instructions. How many? 256 instructions. Okay, so now if you see, the programming language that you use is machine language is understandable by the microprocessor, but we are using the assembly language. So please note down assembly language program. गेट ESE दोनों में लेना पड़ता है भैया. गेट ESE, I'm replying to you, गेट and ESE दोनों में लेना पड़ता है. You have to take gate plus ESE. I'm taking not gate. Why? Because अगर आपने ESE के लिए लिखना बोले तो gate plus ESE लिखना पड़ता है. So please make a note of this. See, for example, if you see assembly language, how you will take. I'm taking one instruction here. So this is the opcode, this is the operand. So when I'm mentioning move immediate a comma 2h, so this is a destination, this is a source and this is a destination. Move immediate means the value 2 is going to be copied into the register A. So copy the value 2 into register A. Next, if I'm saying move immediate b comma 4h, move immediate b comma 4h, the value 4 is copied into the register B. Okay. Next, add B means what? The contents of A and the contents of B both are added and the result is stored in A. Okay. So both are like that. A is added to the B. So that is what assembly language. Okay. So it is specific to processor. Depending upon the processor, the assembly language will change. Okay. For example, assembly language of 8085 is different from Motorola 6800. Why? Because in Motorola 6800, the registers are different. In 8085, the registers are different. So definitely the instruction set and the programming also get differ. Is it clear? Pata tutorial. Chalo. Now let us go for this classification of instructions. So let me explain you classification of instructions. So instructions can be classified in many ways. Explain the classification of instruction. So classification of instructions, we see the first one is a 1 byte instruction. So this is a 1 byte instruction. So move C comma A, this is 1 byte. Add B, this is 1 byte. CMA, complement accumulator, this is 1 byte. Okay, so these are the 1 byte instructions. All the register addressing modes are 1 byte. The length is 1 byte. So if you see the machine code, this is actually opcode, the binary code is this. So this is 1 byte. So the microprocessor understands only this, but for our convenience, we are using this. Okay, so now let us go for this 2 byte instruction. So when I say 2 byte instruction, move immediate a comma number. So this is a 2 byte instruction, before comma 1 and after comma whatever the number is there. So before comma and whatever the comma. So before move immediate data is suppose 3. So this is a 2 byte instruction. I replied you, Patak. I replied you. So move immediate, suppose if I'm writing a number, move immediate a comma 44. or A,21. If I'm writing A,21, so this is opcode and this is another operand. So this is byte and this is also byte. So 2-byte instruction ho gaya. So let's go for this next 3-byte instruction. 3-byte instruction means jump 2085. So jump 2085 means, so jump is an opcode. So this is an opcode and here comes the address. Okay, like this. 2085. Next. Now the classification of instructions, if you see, so these are the classification of instructions. So one is the data transfer instruction, other one is the arithmetic instruction, logical instructions. So please make a list of this first. We'll go step by step. There are 5 types of instructions. One is the data transfer instruction. Next comes the arithmetic instructions. Next comes the logical instructions. Next comes the branch instructions. Next comes the control instructions. So first let us start with the data transfer instructions first. So in data transfer instruction, we have various categories. So instruction set is also one of the important. He can ask you the conventional question, or at the bottom you can give the list of the instructions. At the bottom you can give the list of instructions. So if you see, so before this actually we have to talk about addressing modes. In addressing modes now, we have both the source and destination, both are registered, then that is called the register addressing mode. And one is the source, other one is the memory location, that is what's called direct addressing mode, register direct addressing mode, indirect addressing mode. There are certain things. So if you see now, these are different sources. Move RD comma RS, that means from register to register. So what is this happening here? So this is happening from register to register. So this is happening from register to register, source register to destination register. What is happening? This is happening from register to register data transfer. Next, this is happening from register to memory, and this is happening from memory to register. Memory to register. Register to register, register to memory, and memory register. This instruction copies the contents of the source register into the destination register. The content of the source register not altered. So move B comma A. So these are the memory contents. Okay. So examples I am giving. So example for this is move B comma A. This is one example. And example for this is register to memory. Move M comma B. And example for this is move C comma M. Okay. So these are the. So I am giving the examples. These are not necessary. Another one, this is also one immediate addressing mode. So examples for this is, so here I'm giving a register name and into the register I'm sending the data. So move immediate, I'm taking register B, into that I'm sending a value 60H. So the value 60H is going to be entered into this. Next, move immediate M comma 40. So here, whatever the value is there, that value 40 is going to be loaded into a memory location pointed by the HL register. We don't have any specific register called M. We have a HL register pair, that HL register pair is equal to pointed by the M. Okay. So the 8-bit immediate data is stored in the destination register R memory. R is general purpose 8-bit registers A, B, C, D, HL like this. So I have given the examples. Done. Chalo. Next one is the another data instruction, load accumulator 16-bit address. So this is a load accumulator 16-bit address. So we have to give the address LDA 2000H. So this LDA 2000H. So the contents of the loaded from 2000 memory location, the content is loaded into the accumulator. So LDA 2000H means load accumulator by the contents that are present in 2000H memory location. So if you're taking the 2000H memory location, so this is a 2000H memory location. In the 2000H memory location, whatever the content is there, that is loaded into the accumulator. So 2000H is a memory location. See, before that, A is empty. 2000H is a memory. So 2000H is a memory location. So in that memory location, we have a value. So in the value is equal to 30. So that's 30 has to be moved into 2000H memory location. So LDA 2000 means, so the contents which are present in 2000H memory location, that has to be moved into the accumulator. So the accumulator value has become now as 30. That's it. Chalo. This is also LDX. See, LDXD means what? See here. LDXD means whatever the D register pair is having, that is taken as address. In that address, whatever the content is, that is going to come here. Load accumulator A with the contents of the memory location whose address is defined with the BC or D. So I have mentioned D here. So D register pair is having such a content called 4000. It will go to the 4000 memory location. In the 4000 memory location, whatever the data is there, in the 4000 memory location, whatever the data is there, that is going to come into the accumulator register. So that's the meaning of this particular register LDXD. So I can see the example here, before and after. So D is a register pair, so that is 2030. So this is D is 20 and this is 30. So 2030 is the address. In the 2030 address, we're having a value called 80. So when I say LDAXD, so the value that is present in 2030, that 80 is going to be loaded into the accumulator. So 2030H value is going to be loaded into the accumulator. Please make a note of these points. Note down. Noted? So 2030 is a memory location. In that memory location, 2030 is taken by the D register pair. In that we have a value 80, so that 80 is taken back. Chalo. Next. STA. Next one is the STA. STA 2000H. What is this STA 2000H will do? The contents of the accumulator are stored to this one. So this is the accumulator and this is the memory location. So this is a memory location. So in the memory we are having 2000H is the memory location. So contents of the accumulator. So this accumulator value, for example, let us take 50. So this value is going to live here. Store the accumulator. So contents of the accumulator are called 2000H location. A is equal to 50. So 2000H. So the 50 is going to be loaded into the 2000H location. Store the accumulator. LDA means taking the memory location to this. So LDA, STA both are opposite. LDA 2000H means what? From the 2000H memory location, whatever is there, that content is going to belong to the accumulator. Next, STA 2000H means what? The contents of the accumulator are copied to the 2000H location. So these are the things, LDA, STA. Okay, so note down. Got it clear? Sure. Next instruction, data transfer, is exchange. So what this exchange will do, what the exchange is going to be do, the exchange is going to transfer the registers content of H are exchanged with the contents of register D. That means HL both. So if I say HL and this is DE, the contents of H are copied to D. So this is HL DE. So this is like this and this is like this. This is like this. This is. Please note down. And exchange with D register pair. Okay, so that's it. So see, for example, before and after, before this H is equal to 70 and L is equal to 80 and D is equal to 20, E is equal to 40. So exchange means now what happens? See here, after execution, HL will be exchanged. The contents of H will be copied to D, the contents of the D will be copied to H. the contents of L will be copied to E, the contents of this will be copied to this. $70 will go there, $20 will come here, $80 will go there, $40 will come here after the execution. So that's it. These are the before and after execution. Next comes the another data transfer instruction is PCHL. PCHL means what? The contents of the PC and HL. The contents of the PC and HL are interchanged. So the contents of HL will come to the PC so that the PC will jump to the next location. For example, before one instruction PC is equal to, suppose before an instruction PC is equal to 2000. So at the 2000 the program is going to be run. So but I wrote PCHL. So it is somewhere at 2000 I am going to, after 2000, 2002. Next instruction to be executed is 2002 suppose, or 2001 suppose. It may be 2001, it's suppose here. So here I am written the PCHL. If I written the PCHL, at that moment suppose HL is equal to 3000. HL is equal to 3000. So the PC will become as 3000. PC will become as 3000. So the PC will go to 3000 location. PC will go to 3000 location. Make a note of these points. That means we are changing the direction. PC where it has to go, where it is going. See, the load program counter with HL contents. So the contents of the register H and L are copied into the program counter PC. Okay, so the contents of H are placed as a high order byte. Okay, that's fine, whatever it is. Chalo. Now let us move for in and out instructions. In and out instructions are not data transfer instructions, but they are going to make the business from the external side. So these are microprocessor in and out. So this is 8-bit port address, copy a data to accumulator from a port with 8-bit address. Suppose there is a microprocessor here. So this is 80H address. This is a 80H address. So this is the accumulator. So from there it has to come. So from external whatever is there, from the 80H memory location, the contents has to come to the accumulator. Copy a data to accumulator from a port with 8-bit address. The content of IO port are copied to the accumulator. So that is a in 80H. In 80H means 80H is the port address. So from that port address, the content has to come to the accumulator. That's a point. Okay, chalo, next. This is, see here, port 80H is having 10, the accumulator is there in 80H. So after the execution, what happens? The A will become as 10. Note down. Okay, chalo. Next, similarly, from the accumulator, it has to send something to the outside, that is out. So out 50H, that means what? Suppose this is the microprocessor. So this is the accumulator. So from this, the value has to go out. Okay, so out 8-bit port address. Suppose this is a port address. Let us take 90H. So this is a 90H is a port address. Copy the data from the accumulator to a port with the 8-bit address. The content of the accumulator copied to the IO port. So out 50H. So out 50H. Out 50H or 90H, whatever it is, address, that is address. So before execution and after execution. Port 50H is having value 10 and A is having 40. Okay. So out 50H means what? The content of the accumulator is going to be coming to the port. So the value 40 will come here. Now let us move for the next instructions, arithmetic instructions. Okay. Please remember, next instructions are arithmetic instructions. This particular 8085 cannot support multiplication and division. It supports only addition, subtraction. Note, 8085 microprocessor does not support mul and division. Please note down this. 8085 microprocessor does not support mul and division instructions. 8085 microprocessor does not support multiplication and division instructions. So what are supported? Addition is supported, subtraction is supported, increment means +1, decrement means -1. These are the things. Only 4. So now let us see different things. Add R. Suppose if I'm writing example here, add C means what? The contents of the B, C will be added to the accumulator A and the result will be in A. So what I can write? The contents of the C will be added to the A and the result will be in A. Next, add M. Add M means memory location. There is one memory location 2500. In that memory location we have a value. That value, let us take some 21. So that is going to be taken. 21 is added to the A and the result will be in A. Note down. Next. So these are before execution, after execution I mentioned. You can take it off. A is equal to 20, C is equal to 30. So if I'm giving the instruction add C, the A will be added with the C. A will be added with the C. So 20 plus 30, 50. So this is the result. Next, before execution and after execution. Add M. A is equal to A plus M. A is equal to 20. So memory location is 2050. In the 2050 we are having the value 10. Okay. In 2050 we are having the value 10. So the value 10 is added to the A and the result is 30 here. This is 30. 30. Why? Because in 2050 we are having value 10. Okay. So the value is 30. Sorry, 2050 we are having 10. So that 10 will be added here. Okay. That's it. Chalo. So this is a flag list of 8085. Note down the flag list. Both are important. Yes. Yes, Pramod boss. Any doubt? So this the don't care. We are not using the flag lister format. So this is a carry flag. This is a parity flag. So this is the auxiliary carry flag. And this is a zero flag. And this is a sign flag. Please note down. Okay, my dear. So if you see this flag register, how this flag register will work. So flag register format के लिए हमने एक आइडिया एक टेक्निक है. So क्या टेक्निक? I can remember like this. SZAPC. Can anybody tell me a technique? So how to remember this technique? If Sachin is 0, then all play cancel. ऐसा कर सकते हैं. Okay. So you can give like this. If Sachin is 0, if Sachin is 0, then all play cancel. So please note down this. तो ऐसा रिमेंबर कर सकते हैं आप. ऑर्डर, क्योंकि एक बार क्वेश्चन पूछा आईएएस में, आईएएस मेंस में क्वेश्चन पूछा, राइट शॉर्ट नोट्स ऑन फ्लैग रजिस्टर. एस फॉर सचिन तेंदुलकर, दैट मीन्स साइन फ्लैग. जेड फॉर जीरो फ्लैग. ए फॉर auxiliary carry flag. P for parity flag. C for carry flag. So you can remember like that. Is it okay? Fine. Sachin if 0, all play cancel. Yes, thank you very much. Okay, thank you very much. Chalo. Now let us see here how these flags are work. So the 0 flag and the carry flag, sign flag, how they are going to work. Let us see step by step. So if you see step by step, the sign flag. So this is a sign flag. So what about the sign flag? Sign flag is always MSB. Sign flag is always MSB. Okay. Sign flag is always MSB. Sachin is 0, all play cancel. Very good. Thank you. Next, 0 flag. If the result is equal to 0, if the result is equal to 0, 0 flag is set. Result is equal to 0, 0 flags. That was a thing. Next, auxiliary carry means what? In the nibble, when you are making addition at the nibble, at that nibble, if a carry is generated, that is what we call as auxiliary carry. So that means from bit 03 to bit 04, the carry is passed, then that is what we call as auxiliary carry flag. Next, parity flag. Parity flag depends upon the number of ones. If the number of ones in the result is even, then even parity. If the number of ones in the result is odd, odd parity. For even parity, parity flag is going to set. After ALU operation, if the result has an even number of ones, the parity flag will be set. Okay. And carry flag, you know that one. Overflow flag we don't have. Please don't take this overflow flag. Overflow flag we don't have. So let us take with an example. If you go with an example, it will be clear for you. So let us go with an example. So I will take certain data, and in the data I will give the numbers. So from the numbers you have to get the flag status. Suppose if I am performing arithmetic operation, so please tell me what type of flags are going to set from that. See here, I am giving a number here. Move immediate A comma 21H and move immediate B comma 37H. Now I am giving add B and I am saying halt. Okay, I am giving halt. Now at the end, tell me what is the status of carry flag, what is the status of sign flag, what is the status of zero flag, auxiliary carry flag, parity flag, carry flag. Please tell me what is the status. I am adding a number 21 with 37. When 21 is added with 37, what is the status of the flags? How to do this? So when performing the addition, so A is equal to 21 if I am taking like this. So this is 21, that means 0, 0, 0, 1, 0. This is 1, 0 and this is 0, 0, 0, 1. And B is 37, 37 means 0, 0, 1, 1. 7 means 0, 1, 1. So now if I am taking addition of these numbers, so what I am going to get? 1 plus 1, 1, 0. 1 plus 1, 1, 0. 1 plus 1, 1, 0. This is 1. Okay. 1 plus 0, 1. 1 plus 1, 1, 0. 1 and 0. So this is the result. So the accumulator value is how much? After performing the addition, it is 58. Answer is 58. Now please tell me the flags. Sign flag is MSB. The MSB is equal to 0. So sign flag is equal to 0. Next, zero flag. The result is not equal to 0. So 0 flag is not set. So the 0 flag is not set. That is 0. Auxiliary carry, if a carry is generated at the nibble, that means D0, D1, D2, D3 to D4, if a carry is generated, we can take it as a nibble. But that is not happening. So this is 0, 0, 1. So 0 plus 1, 1. So it is not moving here. So auxiliary carry flag is equal to 0. And the parity flag is the number of ones. We check the number of ones here. In the result, number of ones kitna aa gaya? 1, 2, 3. So 3 is an odd number. For odd number, parity flag is equal to 0. So carry flag, is any carry is happening at the last bit to the next? No, it is not happening. So carry flag is also 0. So all the flag status are 0. No flag is going to be set. Maza hi maza. Do you understand this? So that is the flag status. Got it? So that is the content. Any doubts? So that's how the flag register will work, my dear. Okay. So, and the next important thing is the explain the interrupts. My dear students, IES may a question is expected. Explain the interrupts of 8085. Explain interrupts of 8085. Can anybody tell me how many interrupts are there in 8085? Explain the interrupts of 8085. Explain the interrupts of 8085. Can anybody tell me what are the interrupts of 8085? How many interrupts are there and what is the classification of interrupts? Anybody in the options can answer this question? Question here is descriptive question can be asked. Explain the interrupts or explain the classification of interrupts. Okay, 13 interrupts. Very good. What are those 13 interrupts? Can you tell me? Explain the classification of interrupts. Classification of interrupts. So if you see the classification of interrupts, the total interrupts are 13. We are having 13 interrupts. So these 13 interrupts can be classified as 3 models. One is this. One classification is hardware versus software. This is one classification. Okay, another classification is vectored versus non-vectored. Other classification is maskable versus non-maskable. Okay, so these are the things. Done. Very good. So if you see now, yes, RST 0 to 7, RST 4.5, 5.5, 6.5. Very good. So if you see now, what are the hardware interrupts? Let me take the classification again. So let me take the RS hardware and software. So these are hardware interrupts and these are software interrupts. So if you see the hardware interrupts, what are the hardware interrupts? So we can take the hardware interrupts as RST 4.5. So this is also called as trap. So this starts 4.5 is highest. Next least RST 5.5, RST 6.5, next RST 7.5. In addition to this INTR. So these are the 5 hardware interrupts, and software interrupts are RST 0, RST 1, RST 2, RST 3, RST 4, RST 5, RST 6, RST 7. The first time I am writing like this. So total if you check now, so this is 8 and this is 5. So पूरा मिला के कितना हो गया? Again the total count is 5 plus 8, 13 हो गया. Excellent. Similarly, can you write vector interrupts and non-vector interrupts? So what are the vectored? What are the non-vectored? If you check now, vector means which have a direction of ISR. Vector means which is direction, and that means whenever that interrupt is occurred, only a particular ISR is going to be executed. So that is called vector interrupt. Another one is a non-vectored interrupt. Can anybody tell me what are the vector and non-vector? Similarly, maskable and non-maskable. So some of the interrupts we can mask. Suppose when I'm taking the class, if a student comes, if a latecomer comes, I can mask him, I can stop him. But if HOD comes, I cannot mask him. So that is a non-maskable. Non-maskable. Okay. So can you give me the list of this? Vector and non-vector list and maskable and non-maskable list. What we can write? So see here, vectored are 12. Vectored we can take 12 vectored and 1 non-vectored. So 1 non-vectored, 12 vectored and 1 non-vectored. Similarly, 12 are maskable, 1 non-maskable. Okay. Now what are those 12 here? So all the hardware interrupts vectored, that means RST 4.5, 5.5, 6.5, 7.5. Next, all the softwares RST 0 to 7, they are having certain direction. But only one fellow, which is the INTR. INTR is a non-vector interrupt. Why? Because when INTR is generated, you don't have any direction what to do. You don't know what to respond, how to respond. Okay. Chalo. Maskable means same. Similarly, we are having RST 0 to 7, they are maskable. RST 5.5, 6.5, 7.5 maskable. But only the RST 4.5, which is also called as a trap. RST 4.5, which is also called as trap. So if you see now, here one non-maskable interrupt is there, one non-vector interrupt is there, and 8 software interrupts are there, and these things. Any doubts? Good. Non-maskable is Balamani. Sorry, non-maskable is RST 4.5. Trap. Nice. So these are the things. So this one excellent question asked in the interrupts. Okay. So please see on the hardware interrupts, you can see this. Actually in hardware, this is a 8085 pin diagram. In the pin diagram, you can see these interrupts. So how these interrupts are working? So my dear student, this is a trap RST 5.5, 6.5 up to this. So these are the interrupts. If somebody wants to disturb this particular microprocessor, they have to go on these channels. If somebody is traveling on trap channel, somebody can travel in 7.5 channel, 6.5 channel, 5.5 channel, INTR channel like this. Okay, and INTA bar is like this. So this is trap RST 7.5, 6.5, 5.5, INTR, INTA bar is like this. So now if you check now, so what I'm talking, suppose parallelly all these interrupts came. Here one interrupt came, here one interrupt came, all the students came at a time. Who is given the highest priority in this? Trap is given the highest priority. So whenever a program is under execution, I am executing a particular program, बाहर से मुझे एक disturbance आ रहा है, then interrupt is happening, then what the microprocessor has to do? Microprocessor has to execute the present instruction under execution. It should not disturb that. The present task has to be completed and it has to acknowledge the interrupt first. I am going to answer you. So by making INTA bar is equal to 0. If INTA bar is equal to 0, I am acknowledging you that I am going to handle your interrupt. समझ में आपको? So INTA bar is equal to 0 means I am going to acknowledge you like this. So interrupt is acknowledged and after that it is going to a particular procedure. It goes to a particular procedure called this ISR. So this interrupt service subroutine is going to be executed. So what is called, when interrupt is happened, it will go to certain procedure. That procedure is called ISR. ISR stands for interrupt subroutine. So interrupt subroutine execute करने के बाद, so वहां से पूरा execute करके, then it will come back to this particular line and will go back. It is just like you are in your home, suddenly you got a missed call from your village, some death news, you will go to that village, that particular village. Your grandmother has died means you will go to that grandmother village only, not another grandmother village. Am I right? So who is particular interrupt, that particular ISR only you will go na? Somebody died means you will go to their death ceremony or another death ceremony. So you should have that address. कहाँ जाना है, मैं किधर जाना है, किधर से वापस आना है. So इधर जाने के लिए PC address change होगा, इधर PC address will be changed to ISR address. You will go there. वहाँ काम करने के बाद फिर किधर वापस आना. You have to come back to your plot, not your neighbor, auntie or uncle's plot. So you should know where you have to come back. Again the PC has to be changed and you have to come back to your home, not your neighbor's home. Don't do like that. Don't knock others' doors. So complete your task and execute and come back. So what is the context here? Whenever interrupt is happened, first of all, the microprocessor has to complete this operation. It has to acknowledge that interrupt. I am going to answer you. Don't worry, I am there for you. Then I have to move with my vehicle, change the address to that particular procedure. I should know what to do, what not to do. When something happened, what to do, I don't know. So that particular thing is called direction, vector direction. So I will go to the ISR and I will execute, and after the operation is over, I have to come back to my home. So this is how the interrupt cycle will work, my dear students. Any doubts, my dear students? Okay, enough for today. So in the next classes, we'll discuss baki sab things. Any other doubts? Enough for today. Any doubts? मस्त पढ़ा आप. थैंक यू शिवांश. नमस्कार सर. आईआईटी एनआईटी में इंटर्नशिप मिलती है क्या सेकंड ईयर में, और कैसे ले सकते हैं? आपका सीजीपीए पर डिपेंड करता है भैया. आपका सीजीपीए के ऊपर डिपेंड होता है वो. आपका सीजीपीए 8.0 है तो आपको एनआईटी आईआईटीज में भी आपको इंटर्नशिप मिलेगा. बहुत अच्छा इंटर्नशिप मिलेगा. आप वहां से जा सकते हैं. आईआईटी खड़गपुर, बहुत सारा इंटर्नशिप्स आ रहे हैं आपके लिए. थैंक यू वेरी मच. थैंक यू शिवांश. समझ में आपको ना पूरा कंटेंट?